Hello and welcome to the next video of REFramework series. In the previous video, we already saw why we need REFramework and also understood the concept of transactional processes. We also saw how transaction process helps us in scaling automation. Well, in this video, we are going to explore the next concept that is also known as the state machine. So without wasting any time, let's have a look at the agenda for this video. So in this video, first we'll see what is a state machine, and then we'll also explore how they are different from the flowcharts. And then we'll make a comparison between the state machine and the flowchart, and thereby understand why we prefer state machine for complex processes. Now, in order to understand the state machine, we'll take the example of a light bulb. Well, this light bulb is simulated by an external factor, which is the sunlight. So whenever there is sunlight, the bulb is switched off, and the moment there is darkness, the bulb is switched on. Now, in order to represent this bulb with a state machine diagram, we need to first think about what are the number of states that are available. So in this case, we have only two states. The state 1 is nothing but the on state when the bulb is switched on. So let's call it state 1. And the action that is happening inside is that it's switched on. Similarly, we have another state, state 2, and this is the off state where the bulb is switched off. So when we move from state 1 to state 2, we need sunlight. So the condition will look something like this, that sun is equal to yes. And now, when we move back from state 2 to state 1, that means the light bulb has to be switched on. In that case, it needs to be darkness. So the condition would be sun is equal to no. So if you see here, this particular light bulb can be represented by two states, wherein state 1 is on and state 2 is off. And in order to move between these two states, we have two conditions marked in yellow. The first one is for state 1 to state 2, and the second one is for state 2 to state 1. Both of these conditions together, in the language of state machines, are known as transitions. So now if we had to summarize what we just saw here in order to define what state machine is, there are basically these 3 points. The first point is that a state machine is nothing but a simple visual depiction of a behavioral model. So in our previous case, this model was nothing but switching on and switching off of a light bulb. And then the second point is that a state machine can be exactly in only one of a finite number of states at any given point of time. So that means, irrespective of how many states are available, at any given point of time, it will be only in any one of these states. And then the last point is that the change from one state to another state is dependent on some external input. And in our case, this input was if the sun is there or not. Now let's move forward and think of the building blocks of a state machine. In a state machine, there are basically two major components. The very first one is the state itself, and the second one is the transition, which triggers the switch between different states. So if you see here that if a condition 2 is satisfied, then you move to state 2, and in case of condition 3 is satisfied, then you go to state 3. But now as a next step, let's try and understand how a state machine is different from a flowchart. Or why do we need a state machine when flowcharts are already there? For that, what I would do is, I would just divide this sheet into two. And on the left hand side, I would make the state machine depiction of the automatic light bulb. And like we already saw, there were two states. State 1 and state 2. State 1 was the on state and state 2 was the off state. And in order to transition from these two states, If the sun is equal to yes, then you move to state 2. And if there is no sun, then you come back to state 1. So this is a very easy representation of the light bulb. And now we're going to take the same example and try to represent it into a flowchart. So the very first step is a start. Thereafter, there is a condition box. Which checks if there is light, yes or no. If there is no light, in that case, the switch is turned on. And if there is light, then the switch is turned off. And since this is a continuous process, there is no end state, and this has to be a continuous loop. And so you go back to your condition box, and this loop keeps continuing. So now if we just compare our left hand side to the right hand side, you would see that the left hand side is a very simple representation of the light bulb as compared to the flowchart. And this representation becomes even more complex in case you have more conditions. Now, in order to understand this complexity, let's try and make our bulb more sophisticated. That is, now a light bulb is switched on based on the inputs of two sensors. The first one is the light sensor, and the second one is a movement sensor. So whenever there is darkness and there is some kind of movement in front of the bulb, only then the light is switched on. And the moment the light is switched on, there is a timer that's been initiated for 10 seconds. And the moment the timer is past those 10 seconds, the light is again switched off. And in order to represent that situation, you would see that on the left hand side, we again have the state machine representation, wherein you have again two states. The state 1 is the off state and the state 2 is the on state. And in order to move from state 1 to state 2, there is a condition to check if there is movement and there is darkness. Only then you go to the on state. And there is a timer. That means once the bulb is on, the timer is set on. And once the timer is over, the bulb is again switched off. Or the other situation would be that there is light and the sun has come up. So it will again be in the off situation. So if you see, this situation is also just represented by two states in a very simple way using the state machine. But on the other hand side, if you go and look at the flowchart, the representation is much more complex. And the only reason why we are using state machine instead of flowcharts is because of how simply you can represent complex situation using state machines. And with this, I would move to the next slide to just have a look at the reasons why we are using the state machine. So like I already explained in the previous slide, that complex transitions are very easy to represent using a state machine as compared to a flowchart. So that is a very valid reason. Another reason is that the state machines wait for a condition to be true before they go into transitioning. So this is something which is very useful in case of automations, that you remain in a state till the time you don't get a trigger to move to a different state. And in order to represent continuous running automations, state machine is an ideal choice. And I hope now it's very much clear to you what state machines are and how they're different from flowchart and the reason why we use state machines. That's all as far as state machines are concerned. And if you have any questions, then do post in the comments below. And in the next video, we'll be looking into the REFramework to understand its design and the operating model. So see you again in my next video. Until then, stay safe and keep automating.